All right, 11.2, comparing data sets. So now we're going to have two sets of data, and we're going to compare them. All right, let's get started. So looking at two dot plots here, we're going back to fuel efficiency, miles per gallon, and Sawyer is deciding between a type 1 car or a type 2 car, whatever categories he's put into them. He's decided that highway fuel efficiency is his most important feature, and so the data you see on the screen in front of you is exactly that, highway fuel efficiency. All right, so which car should he choose? Well, if we look at type 2 cars, okay, right here, most of the data is at 37 and above, okay? So most of those cars are getting at least 37 miles per gallon compared to type 1, which is more 33 to 37. So if we look at which one is best, we're going to say type 2 is better for highway fuel efficiency. The data from type 1 is clustered between about 33 to 38, whereas type 2 is somewhere between 35 or 37 and 44. Okay, so we'll go 35 to 44. So in that case, he wants better highway fuel efficiency, he better get a car from type 2. All right, moving on to box plots. Remember, box plots do not give individual data values, but they make it very nice to support trends amongst data. So you can see here between Caitlin and Philip, they both had the same minimums and they both had the same maximums, but the middle part of the data is significantly different. All right, so they're talking about charity fundraisers here, and Caitlin says that her school, Caitlin's the top box plot, did a better job of raising money than Philip's school did. So does the data support Caitlin? Well, let's see, the median for Caitlin was right here. So the median was somewhere around, I don't know, 45 maybe, whereas the median for Philip was at 50. If we look at quartile 1, we're at 45 for Philip, but we're down at like 32 for Caitlin. So I would say that the data does not really support Caitlin's claim. So no, the data does not support Caitlin's claim. The maximum and minimum are the same, but the spread of the data varies quite a bit within. Okay, so 50% of students at Caitlin's school raised between $32 and about $52. Whereas that same 50% at Philip's school raised between 45 and 56. Okay, so they raised a bunch more money at Philip's school. Okay, if we compare the medians, Caitlin's school raised $45 compared to Philip's 50. So according to this data, Philip's school, those students in that random sample of 30 students, raised more money than Caitlin's school did. All right, histogram. So we're going back to that marketing team. We're looking at the age of random samples of viewers of two different TV shows to decide where to market a specific advertisement. So if they know that their product is marketed towards 20 to 29-year-olds, which show 1 or show 2, is better? Let's see, we got to look at the intervals. So 20 to 29. So right here. Wow, there's a lot of people between 25 and 29, but this 20 to 24 is completely empty. Over here, we've got, it's kind of evenly distributed. And if we count, we've got, let's see, 3 here and another 5 here for 8 and 8. Oh, this is like 5. Just about 5. Yeah, so about 8, 7 or 8. And show 1 had about 8 people. So they're fairly even. So which one is better? You'd have to justify that. So you got to explain it. Okay, let's see. So show 1 and show 2 both have 8 viewers within the 20 to 29 year age group. Now, which is going to market towards a wider variety of people? Probably show 2, because they've got both age brackets represented, whereas show 1 only has that older age bracket. So that means in this case, show 2 is probably the better bet because it focuses on all ages, whereas show 1 only has viewers in the larger age bracket, that 25 to 29. Okay, so it has a wider appeal. All right, moving on to our box plots. Now remember, we said we're going to make a box plot once by hand, and then we're going to make Desmos do it. So let's do that right now. So we're going to create a box plot, actually 2 box plots, comparing the average number of texts on school days on the left to non-school days on the right. We need our 5 values, min, Q1, median, Q3, and max for each data set. All right, so I've taken my average number of texts on school days. I've dropped that into Desmos. Okay, so I just typed them all up here with a comma in between. So I can see there were 15 items. I can see all of my different statistics here. Mean, which we don't need for a box plot, median, Q1, Q3, max, min. All right, so I got all those values. And then I did the same thing over here for my non-school days, and I've got all my values. All right, so I'm going to come back. I'm going to copy them down onto my paper. So let's see, for non-school days, my minimum was, or for school days rather, my minimum was 0. Q1 was 9. Median was 17. Q3 was 22 and 26. For non-school days, my minimum was 0. Q1 was 40. Median was 50. Q3 was 60. And my max was 80. All right, so I've got my number line here. I've got it evenly distributed. And let's see. So I'm going to start with school day first. I've got a minimum of 0. Q1 of 9. Median of 17. Q3 is 22. And max is at 26. It's getting a little squished. Okay, so there are my 5 number summary. So we got 0, 9, 17, 22, 26. Okay. Yeah, I'm going to make this a little bigger so I can write a little nicer. Okay, so I gotta make my box plot. So let's see, we connect the middle with my box, line down the middle at the median, and then connect the whiskers. And then this is the number of school days, so make sure this is labeled as school days. And then we repeat the process for our non-school days. So we've got a minimum at 0. And I'll just do it below the number line. Now, this is possibly an outlier. So let me just move on from that for now. We got 40 and 50, 60, and 80. Okay, so my IQR is 60 minus 40, so 20. So IQR equals 20. So when I put that data out there, that 0 seemed really far away from the rest of them. So to be really far away from the rest, what does really far mean? Well, it has to be more than 1.5 times the IQR below that Q1. So if I did Q1 minus 1.5 times the IQR, 20, and Q1 is 40, so let's say that's 40 minus 30 is 10. So anything below 10 is an outlier. So instead of putting the dot here for 0, that's going to go away. And let's see, my next point is 20. So I'm going to move this to 20. And then I'm going to put that asterisk, reminder that star at 0. And then I can make the rest of my box. There's the rest of my box plot. And don't forget to label non-school days. All right, and then the last piece here, let me take this back down to a better zoom. So if I'm asked to draw some conclusions here, what does this data tell me? Well, we definitely send a lot more texts on non-school days. Zero texts is an outlier, meaning it is more than 1.5 times away from the Q1 value. We would also say that non-school days have more variation in the number of texts. Because if I look at school days versus non-school days, the range, well, that's my maximum, 26, minus my minimum, which is 26. And then for non-school days, it's 80 minus 0, which is 80. So there's a lot more diversity in the non-school days in terms of texts. All right, that is 11.2, comparing data sets.